Hello and welcome to this series on named entity recognition for the purposes of the digital humanities. In the last 9 or 8 videos or so, what we've looked at is how to do some custom NER work. However, we have been using the entities that are kind of industry standard, person, location, tags of that nature. In this video, I'm going to start breaking the series into two different forks. One fork is going to be on custom labels for Holocaust specific data, and another fork is going to be for my Latin NLP series, and that's going to fork off into custom labels for Latin NER. The purpose of this is to show two different domains and two different languages that present two different sets of problems and show how we can solve them for these two different groups. So lessons 09.01, etc. will be for the Holocaust, and lessons 10.01, etc. will be for Latin named entity recognition. I encourage you to kind of go to the one that you find most useful and beneficial. The reason why we're doing custom labels is because oftentimes when you are working with a data set or with a data from a specific domain or content area, such as the Holocaust, South Africa, medieval Latin, you are not going to just need the standard off-the-shelf domain or standard off-the-shelf labels. You're going to need domain-specific labels. And so think about what this might be. If you're passing in a whole bunch of Holocaust-specific documents, it's going to be very useful to extract things like person and place, but place can be very, very tricky. The way in which places are referenced in Holocaust documents can be very specific and be very general. So a place could be anything from a general location. It could be a state, as in a national state. It could also be, and these are things that are not built in too spacey. A state would be something like a GPE, a geopolitical entity. A location might be something like the Rhine River, a natural entity, a natural boundary, if you will. But things that are also very important to Holocaust documents are things like concentration camps. So a specific kind of place, or a ghetto, a specific kind of place. Here is where this becomes very tricky. You have to get a computer to understand the nuances of a place. How do you get a computer to understand when a word that could be a city is not referring to a city generally, or but rather a ghetto specifically? How do you get a machine to recognize when a term that is being used that is a place is being referenced as a concentration camp? Again, there are two ways to solve this problem, a rules-based method and a machine learning-based method. I'm going to go over, from here on out, a machine learning-based method approach while using a rules-based method, as we saw earlier in the series, to generate a basic training set to get a model off the ground. So in this series, we're going to be trying to teach a computer simply two things. We're going to try to teach it actually probably just concentration camps, and we'll do a little bit with ghettos as well. So let's jump right in. In this video, we're going to be talking about one major issue, and that is gathering the data. Oftentimes in my videos, I'll get comments in the comments section that ask, where did you get your data? And the answer is always the same: on the internet. A lot of times this is going to be the case. The reason is because it's accessible, it's there, and you can often pull from many different sources to get a really good training set, or a good data set. In this case, I'm going to be trying to obtain, for this video series, a data set on concentration camps. So if you were to go to Google and type in list of concentration camps, you're almost always going to get, if you type a list of anything, a Wikipedia link. So you can click that and you'll be able to see that you've got some really good data right here. Now, Wikipedia has a bad name, but in the NLP world, Wikipedia is a godsend. And the reason why is because it is oftentimes, in a lot of languages, the #1 provider of textual data. And not just textual data, structured textual data. So this is nice because were I to want to just do some simple web scraping, I could go here and grab all of these camps right here. I could grab a list of subcamps, and I could actually go through and find all the subcamps. And this is really important also for our purposes. I could go through and grab these specific metadata associated with that camp. So I could grab the location, which allows for me to do something known as entity linking, which we're going to see a little bit later in this series. This is when you provide toponym resolved linkages to regionally agnostic uh, queue numbers. We'll talk about that in a later video in entity linking and spacey. But you can also grab all of this extra metadata. The problem is while Wikipedia is very useful and very good for NLP problems, it's not always good for historically accurate information. And so I would caution against using a lot of this metadata without further checking or verification and academic presses. But again, you've got a good list of data here. However, when working with something as delicate as the Holocaust, you really don't want to rely on Wikipedia for your labels. I would encourage you to use either an academic or a museum institution that has some kind of good peer review in the process, good methodology for collection of metadata. And for that reason, I would recommend using something like the United States Holocaust Memorial Museum. If you go to their page and try to do a search, you'll find that you can control your search by various metadata parameters. So this shows you the number of places where this specific concentration camp is referenced. And as you might expect, some of the larger ones are going to be things like Auschwitz and Dachau. So how can we use this data to start cultivating a data set of concentration camps? There's a couple different ways. You can go to my videos and look at how you can do web scraping to grab this metadata, or in this case, I would recommend just copying and pasting. I can copy and paste all of this data into something like a text file that I'm going to call camps.txt. This is not a very fancy way of doing it, but it actually works for our purposes. And I'm going to open up this formatter.py script that I'm going to just write a few simple commands in. And so I'm going to use my Stream Deck because I've gotten really lazy recently. I have to always paste this in, and I just wrote out a little function on my Stream Deck that allows for it to automatically populate. If you don't know how JSON files work, please do watch my videos on JSON files, and you'll understand all of this fairly easily. It's going to allow us to load in and write JSON data. But for right now, I want to simply import RE, which is going to be regular expressions, regex. And I'm going to say with open, and I'm going to grab that text file, data.camps.txt. I'm going to open that as readable. And then what I'm going to do is say open it up as F. And then I'm going to say lines are going to be equal to f.readLines. And then this is where I'm going to iterate across it. For line and lines, I want to create an object called results. I'm going to do re.findAll. So I'm calling that regex library. And I'm going to say I want to grab every instance of a word that starts with A to Z. So that's going to be our concentration camp in this text file. So every line has got a concentration camp followed by what is clearly a tab and the number of documents that it appears in. So I'm going to grab everything, do something a little greedy, grab all the stuff that's there between that and the instance of a tab. And let's print that off so you can see what that looks like. And we've got a syntax error. What have I done for line and line? For line and lines. Oh, there we go. For line and lines. And there's one other thing that's going to return an error. I got to tell what string to grab. And if you notice, it looks like a list of all of these different names. Fantastic. I'm very happy with that. And I want you to pay particular attention to this right here. The Polish letters, the O accent, and the L with the line through it. We're going to be addressing that in the next video when we talk about cleaning our data and standardizing our data for optimized OCR or for optimized NER. So now that I know this is going to be the first index, I can do something like that. And I also don't want to have that /t, which is a tab, in there, so I can do that. And now I can print off the results, and I've got all these concentration camps properly formatted now. So I'm happy with those results. So what I can do is I can go and use my write data function. And so I can simply say write data, and I'm going to pass in two arguments. I'm going to pass in the file. In this case, I want it to be put into data /camps.json and the data that I want to pass to it. And for this, I'm going to create another object which is going to be called camps. It's going to be an empty list. It's going to be camps.append, and that's going to append the results there. And I'll print off camps so you can kind of see what it looks like. And there we go. What we have now is a camps JSON file. Don't worry about this. This is the way JSON renders non-Latin letters in HTML /U codes. So what this is a JSON file of cleaned concentration camp textual data. This is going to be the data set that we use to identify and create a training set in spaCy in the next videos for training a custom NER model with custom labels. That's going to be all for this video though. In the next video, we're going to start using this data to train a custom NER model. Thank you for listening. If you've enjoyed it, please like and subscribe down below.